So in today's class, we will be talking about how we can use IoT concept in industrial scenarios. Okay, so it is not actually something difficult. Okay, so I will only erase the part which is regarding the. So I will erase only this part. We will talk about the industrial IoT in today's class. So, industrial IoT is not that different from the IoT, the general IoT. The industrial IoT is differing mainly from the equipment that is used in the IoT network in terms of the sensors and the processing units that we use to process the data. So we have sensors which are like temperature sensors, pressure sensors, fluid monitoring sensors, and so on at the industrial scenarios, right? So I don't know whether you have participated in the industrial training, but once you go to industrial training, some of you may have seen how the industrial environment work. Okay, so in there actually we have different production lines. Okay, so I will first write in today's class. We are going to be talking about the industrial IoT, about industrial IoT systems, right? So industrial IoT systems is basically talking about manufacturing facilities like factories which produce some products, right? So manufacturing facilities and logistics logistics and services related to that, and healthcare systems. Okay, so these are some of the examples where we use industrial IoT, which is more different. I mean, a little slightly different from the IoT networks in terms of its environment. So the only difference is the environment is different. So in these industrial scenarios and in these healthcare systems, the environment is challenging, more challenging, and it requires more robust sensors and communication systems in order to address the challenges that suddenly come up in that area, right? So so let's take, for example, the manufacturing facilities which produce some products. So we have some manufacturing facilities with some product when where we are, for example, where we are creating some products, right? So let's say we are talking about the orange like factory which is producing some electronic equipments or some switches and so on. So once we are having these kind of equipments produced in a production line, we need to have sensors along these production lines to monitor the condition of the products, right? So we can have cameras, for example, we can have cameras, we can have like if it is like if it is so cameras can do a lot of things. They can actually see the quality of the product and whether it's having faults or not. Apart from that, if we are having other kind of measurements, we can have like pressure or something like that. So pressure, temperature, humidity, those things also we can check if it is needed. So we can have different measurements. So the main difference is that when we are the sensors that we are using here are more robust than the sensors we are using in our homes or in our offices, where the challenging situation is not available, right? So in factories we need to have very robust sensors which can which can withstand any type of environment changes that can happen in terms of pressure, temperature, humidity, and so on, right? So these are some of the sensors that we can use in a production line. So if we if we take electronic equipments, we may only need maybe cameras. But if we take, for example, if we are producing something like a liquid or something that is flowing across this production line, or some food product, then we might need to measure the pressure, the temperature, humidity, such kind of parameters in the production line. Apart from that, apart from these sensors, we can also have devices which are monitoring these production lines, or some kind of machines which are installed in the production line or beside the production line to monitor something which is having more computations done than the sensors alone. So we can do some computation using these devices. We can find something, we can count the number of products going through a certain point in the line, and so on. Apart from that, we can have more advanced devices such as robots. Right? We can have some robots, we can have circular robots, which are going on the floor. So these robots can actually be useful for maybe transporting items from one location to another location in the industry. We can have robots. So these robots also are type of device which is connected to the internet. So therefore it is also one of the devices that we can take as IoT devices. And these robots can do a lot of operations. They can move from one place to another location, and they can do multiple tasks. Right? So robots, devices, sensors can all be part of this industrial IoT network. Okay. So once we are drawing this IoT network, we can see that we can connect our processing unit, or the processing unit to sensors, different types of sensors. We can have sensors like, as I said, like temperature sensors, or pressure sensors, humidity sensors, flow monitoring sensors we can have. So these sensors are more robust than the normal sensors that we use for our day-to-day activities in our homes and offices. So in industry, we have a large size and very robust sensors, and these sensors could be connected to our IoT network, and these sensors are connected to the PLC, which is we call as programmable logic controller. Okay, so programmable logic controller. Right? So I think you must have learned about programmable logic controllers before, right? So in your control classes, I think you learn about PLCs. So basically in the industry, we have PLCs to connect the sensors to the rest of the network. Okay, so the sensors are first connected to the PLC, and the PLC is there to collect the information from these sensors and forward them if needed to another location. And also the PLC is able to do some computations also. So the PLC is able to do computations. So therefore PLC is like the embedded embedded controller that can control the computations of the data, or the necessary computations that can be done on the data that is received from the connected sensors. So the sensors could be these temperature or pressure sensors or something like that, or else it could be a device, as I said, some monitoring device, right? Some device which is also part of these production lines, or certain another a device which could be used for some computation. So this could be a certain device. And then there could be robots, right? The robots also could be there. So the robots can also access the PLC. So the robots actually can access the PLC, or if it doesn't want to connect to the PLC, then it can connect to the access point directly as well. So the robots can connect via wireless communication channels to the access points directly, or else if it needs to do computations before connecting to the access point, it can feed the data or connect to the PLC as well. So anyway, we will consider the case where we have the sensors connected to the PLC. So the PLC is then able to do the computations required and send the useful data to the access point, right? So to the network, I mean through the access point. Okay. So the output of this PLC computations will be sent to a certain access point. So this PLC could be connected to a certain router, and the router will be able to communicate the data to the necessary destination, right? So if the industrial IoT system is connected to the internet, I mean, if it is IoT, definitely it should be connected to the internet. So then the router will connect to the public internet, and then through the public internet, the data could be stored somewhere else as per required by the authorities of the industrial environment, or the authorities of the industry, and then another user can access that data. So basically, industrial IoT is like this, where we have set of sensors which are more robust than the normal sensors. So the main difference is in our normal IoT scenarios, we have more like consumer-centric devices, right? Consumer-centric devices like we'll say doorbells and some kind of washing machines and fridge, refrigerators, and so on. So we have some consumer centric, like very familiar equipments connected to the IoT network. However, like in industrial IoT networks, we have more robust sensors connected to the IoT network. So those robust sensors, devices, robots are connected to the network via a PLC most of the time. And so if it is not required, the devices can directly connect it to the access point. Okay, so we can take the router as the access point. So the devices can directly connect to the access point, or else if some computation needs to be done before sending the data to the access point, then the PLC will do the computation, and the PLC will act as the embedded system that performs the local computations. So the PLC afterwards will communicate the data to the local server or the gateway, right? So the PLC will act as the embedded system that performs the local computation. And communicate, and will communicate with the local server. Communicate with the local server, server or gateway, right? So with the local server or gateway, right? So in here, the local server means that the server which is connected to this access point. Okay, so the router which is connected to a certain, the server which is connected to the local router is known as the local server. So in industrial networks, we can have local network which manages uh, the operations in the local IoT environment, in the local industrial environment, right? So we sometimes we do not really need to connect our data to the internet. We might only need our data to circulate inside the local network. In that case, there's no connection to the internet in that case. However, if we do connect that to the internet, then only we have the connectivity to the internet, and it's called then only we call that as the Internet of Things, and industrial Internet of Things. So the router in here behave as the gateway which connect us our local environment, local network to the public network. So if you have any questions, you can ask. So also the PLC is also designed to withstand harsh environmental conditions and provide reliable and real-time updates. Okay, so I will erase this part. So another name that we can give to the PLC is that it is a local edge device, right? So we can call edge devices, devices which are connected to the um, edge of the network. So edge of the network means like devices which are connected to the local network of a certain IoT application, right? So this is the access point, right? The router in here is the access point. So the devices which are connected to the access point we call as IoT edge devices, right? So I mean the devices and all the components in the edge network we call as edge devices. So the server which is connected to the access point also is a edge server. It is an edge server, and PLC which we can call as a edge device. So this is a device which connects to the access point and send the data to the access point. So from the access point, the data will be sent to the local server, and the local server we will be doing the edge computing. So the PLC will be responsible for collecting the data from the sensors. So anyway, we can call this PLC as a local edge device which collect the data and send it forward to the edge server and then also to the internet. So right, so if you have any questions you can ask, right? So we are going to the next topic regarding industrial revolutions and how industrial IoT is included in the industrial revolutions. Okay. Do you have any questions? Right. So if you have any questions, you can ask. Right. So we are talking about industrial IoT, right? So industrial IoT has been introduced in something called Industrial 4.0. Okay, so Industrial 4.0 is part of the industrial revolutions that has happened over the years in the past, right? So we will be talking a little bit about the industrial revolution also in this situation where we need to understand why we have come up to this point, right? So industrial revolution, I'm sure you have learned about industrial revolution that has happened in the world, right? So industrial revolution means like the revolutions that has happened in the Europe areas mainly during the 14th, 15th up to 17th, 18th centuries. Uh, in order to make some revolutionary changes in the industries. So we have seen multiple revolutions happening in that Europe and in those countries in terms of industries and in terms of building new things, right? So industrial revolution has led the world to innovate new equipments and increase their performance over the time, right? Basically industrial revolution has happened in different stages. There has been industrial revolution called 0.0, then industrial revolution 1.0, industrial revolution 2.0, industrial revolution 3.0, and then industrial revolution 4.0. So basically in industrial revolution 0.0, what has happened is that certain some equipment has been introduced into the world, which is known as the first industrial uh, I mean, not industrial equipment, but during this era, the first industrial facility has been introduced, right? So the first industrial facility has been introduced. So therefore, it is known as the Industrial Revolution 0.0. So the first industrial facility has been the printing press, which has been introduced by the goldsmith Johannes Gutenberg, right? So printing press has been introduced by Johannes Gutenberg. So this is actually something history related to history. You don't have to remember these things, but I think it's very interesting to know the history of actually the development of industrial equipments and how we can improve the industrial facilities in using the different technologies that came up with the different eras. And then once we come to the 4.0 era, we are coming to the Internet of Things technology. Okay, so we will see how it came up to that point. So when we are talking about industrial revolution, uh, 0.0 was concerned about the first industrial facility which was introduced, and 1.0 was concerned about the steam engine and how we can use the steam engine for mass productions, right? So steam engine and mass production of products. Uh, so uh, so in that era, we were using steam engine and we were using steam for mass production of products for, in the industry. And then in the industrial 2.0, we have electricity, the invention of electricity, and with that um, we have manufacturing facilities related to many products, and especially steel production has been escalated with this uh, uh, introduction of the electricity and so on. So electricity has been one of the main inventions which leads to the growth of the industrial productions and facilities. And then with 3.0, we have added computer systems to the industries. So we have added computers. So we have added like computational systems to industries, such that now we have factories with computers which are able to automate certain tasks. Right. So once we are going to a certain factory, we see multiple computers and user interfaces showing us the status of the certain operation in the industrial in the industry, and the condition, the temperature, pressure, humidity, and whatever the parameters that are required are shown through computer systems. Now the people do not have to do much of the work. A lot of work has been done by the computer systems. So computer systems had been added in the Industry 3.0 revolution. And then once we come to Industry 4.0, we are adding the connectivity feature. So that is the most important thing for us. So adding the connectivity feature improves the performance of the industrial facility up to the next level, right? So once we are adding connectivity, it means that we are connecting our sensors based our IoT network at the local edge or the local network to the internet, right? So we connect our data across a certain access point to the internet through multiple through the connection to a certain router in the internet, and then through that we can access the internet. So based on that, we can actually do many things, right? The amount of things that we can do, and the possibilities is endless, right? So you can actually think of many things, right? So what you can do, right? So once we have connectivity in our IoT network, in our industrial scenario, then we can do multiple things. So how can we get the advantage? What are the things we can do with the connectivity, right? So we will think about that, right? So one thing is sensor to sensor. Sensor to sensor, we can establish connection. We can have communication between sensor to sensor, or device to device, or machine to machine, or robot to robot, right? So I mean, machine to machine means actually robot to robot, right? So anyway, we can communicate directly between devices once we improve the connectivity in the industrial facility up to that level. If we have a connection between devices, then the devices themselves can talk to each other and do the operations on their own. Right? They can make decisions on their own and do some useful task at the local area. Right? I hope it is clear to you. This is like actually a very useful thing and very like magic, right? So now we don't have to be like, as humans, we do not have to monitor the operations done by the devices all the time. We can let them do the devices on their own. So one thing we can do is we can connect the devices across the devices, I mean between devices, using certain communication technology. So we can use some short range communication technologies like we can take Wi-Fi, right? We can take Wi-Fi, we can take Bluetooth, Wi-Fi, Bluetooth, LoRa, Zigbee. Likewise, there are multiple like low range, I mean short range communication technologies that are available. So we can install these modules, Bluetooth, Wi-Fi, or whatever the required communication module we can install in these sensor nodes, I mean this sensors based nodes, and then by installing the same module in the other sensors also, we can establish the communication between those modules, right? So the sensors, if we take, for example, if you want to communicate using LoRa communication, then we need to have LoRa modules installed in both the devices, right? So the transmitting device and the receiving device must have the LoRa module. So then only the receiving end can decode the data that has been transmitted by the LoRa communication, right? Therefore we can actually install the necessary modules in these sensors, and using that we can establish communication between devices, right? Apart from that, we can establish communication uh, between infrastructures, right? Between facilities, between different industries which are at different locations. So, right. So what I mean is that we can have another facility somewhere here, which is connected, which is connected to the internet in another location. Okay, so we can have certain access point in here. That access point will be connected to the sensors in that facility, which is located in another location, right? So we can have this industry in Hatton, for example, this industry in Colombo. So with this connectivity, when we are enabling connectivity to the internet, we are able to connect two industries of the same brand or something in different locations, and we can maintain the communication between those industries. So if we are fast enough, we can have real-time updates from the other industry. So infrastructure to infrastructure communication can be maintained, right? So infrastructure to infrastructure communication can be maintained. Communication can be maintained. Oh. Okay, so likewise, we can actually enhance the communication. So apart from that, anybody who wants to control or monitor the communication can also monitor the status of the industry by connecting the data of the industries in the connecting the data in the industries to a cloud server. So we can connect the data to the cloud server, and we can store the data there, and that cloud server can be accessed by a certain person who's accessing the network through another router or switch, right? So there could be another user, could be maybe the manager of the internet or the industry, and that manager can access the cloud server using the internet, right? So remote monitoring also can be done by uh, adding cloud computing to this industrial IoT scenario, right? So once we are adding cloud computing, we are able to access that information from anywhere on earth, right? So the user or manager do not have to go to the industries. They can remotely monitor using any location that they are in. Their office could be in US, they could be in USA, but if the data is getting updated regarding these industries in real time or with low latency, then the manager who is in USA can access the data very quickly in real time regarding the industries, and they can check the status of the industry in that location, which is a very useful, powerful thing, right? So that is why Industry 4.0 is saying that connectivity is what is driving the industrial revolution in this Industry 4.0 era, right? Basically that is regarding Industry 4.0, right? So once we are talking about the changes that had been done to the industrial scenario in terms of in comparison to Industry 3.0, there are multiple factors that we can consider in order to show that there has been a significant difference in the industrial scenarios due to adding connectivity to the networks, right? So due to adding connectivity to the networks, we have been able to enhance the computer-based industrial systems that were available in Industrial 3.0. Okay, so we were having computer-based systems in Industrial 3.0, but in Industrial 4.0, we have added the connectivity feature, right? So in Industrial 3.0, we had basically we had the focus on manufacturing certain product, and we were only talking about how we can enhance the manufacturing process. But in Industrial 4.0, we are going to focus on the lifetime of the product, right? So we are thinking a little bit ahead of the product in Industrial 4.0 systems. So in 3.0, we were talking about planning. planning the process. But in 4.0, we are actually implementing what we have planned. So we are actually acting and we are doing trial and error. And from those trial and error, we are learning. And based on our learning, we are improving our performance. Then we are also increasing the smartness of our operations, because now we are actually adding intelligence to our activities by implementing different AI techniques in our manufacturing. So apart from connectivity, we can add intelligence to our devices because of the connectivity as well, right? So because we are able to connect our devices to the internet, the devices can get information from the internet in real time whenever they need, and based on that they can make smart decisions. And they can use smart intelligence to act on the environment that they are in. So Industry 4.0 is making the devices more smarter by adding connectivity to the devices. Right? So earlier we had computer systems, but the computer systems were not able to, like operate the devices in an intelligent manner. They were able to monitor the devices, monitor their performance, but not make them operate on their own based on some data that the devices can collect, right? So that concept is coming because of the addition of the communication aspect into the devices. So based on the Industry 3.0 is uh, making some it's doing its manufacturing focusing on the time or efficiency in manufacturing. However, the difference in 4.0 is that the 4.0 is focusing on smart manufacturing. They are thinking about the overall manufacturing in the global manner, but Industry 3.0 is focusing on how to efficiently get the product done, right? So there's a slight difference between those two, where the smart manufacturing can actually optimize when a device must be or product must be produced, at what time that product must be produced, and like what is the required delay in producing a certain product, because sometimes we do not really need the product to be created really fast. Sometimes based on the type of the product, we might need to delay that production and then focus on more priority devices and create those products in a certain order. So we need intelligence to create such manufacturing facilities. So smart manufacturing is all about intelligence at the manufacturing facility. So anyway, so there are multiple like improvements in terms of manufacturing in the Industrial 4.0 revolution, and in its the features of Industrial 4.0 are basically based on improving the system using connectivity. So many improvements have been done in the Industry 4.0. So you can also refer regarding that once you have the time. So Industry 4.0 is a technical term which is used worldwide. You can search in the Google regarding that as well, and you can find what are the differences that we can find in Industry 4.0. What are the special features that Industry 4.0 has in terms of the performance at the industries in comparison to the previous industry situations, and what is the key factor that made it happen. So the connectivity, as I mentioned, was the main reason for the performance improvement in in the industry 4.0. That is one of the main features, or one of the main reasons for the improvement of industry 4.0 systems, right? Connectivity and intelligence, right? So we need to add both connectivity and intelligence to get the industry 4.0 performance, right? So anyway, we will be ending today's class with that. So if you have any questions, you can ask. So I would like to actually continue this discussion in the interactive classes also in this week, so you can attend the interactive classes. If you have any questions, you can ask. I will end the recording.